Hi guys, video 12 on conic sections here. F is one of the focal points of an ellipse and P is a point in the curve. The eccentricity is 0.75. ECC equals 0.75. We'll expand that in a minute. Part A is draw half of the curve, and part B, draw a tangent to the curve which makes an angle of 45 degrees with the axis showing clearly how the point of contact is obtained. Okay, back to the question again there. So eccentricity of 0.75. Eccentricity is the relation of the distance from the point to the focal over point to the directrix. And 0.75 can be broken down to a fraction of 3/4. That meaning the distance from the point to the focus, is 3 units. And from that same point to the directrix will be 4 units. The axis is given, so the directrix stands at 90 degrees to the axis. And it stands in a position, here someplace, that I know that the distance from here to here is 3 units and that the resultant distance here to here will be 4 units. So that is how we'll position our directrix. To get started, we know what 3 units looks like. Let's find out what 1 unit looks like. So point to focus is 3 units. I'm going to divide that into my 3 units. See what 1 looks like. Take your compass again, random dimension on the compass there. 1, 2, and 3 marks, and sliding set squares to bring them back onto our point focus line. Now, I only need that one. That's all, because I know now that that is 1, 2, 3 units. And what I'm going to do is I'm going to take that line and extend it. I'm going to take 1 unit of measurement, whatever that unit happens to be, and I'm going to add it onto the line. So I have just changed a line from 1, 2, 3 units into 1, 2, 3, 4 units, and I can use that new dimension right there to find my directrix. My directrix is going to be a vertical, and if I wanted to find the point where it is drawn, that's how I do it. So using my horizontal line or my line parallel to the axis, I get my point of contact and I get the position of the directrix D1. Next, so what have I just found? I found a directrix and we have 1 point in the curve. I have a focal point. I want to get my line of eccentricity next. So the other little formula we need to know, of course, is rise over run equals 3/4. So run 4 units, rise 3 units. I'm going to go with a unit of 30 mils. So 4 30s along the bottom is 120. So if I go 4 30s long, I'm going to go 3 30s up. So run 4, rise 3, 3 30s up is 90. And there is my line of eccentricity, coming from the point of intersection of the axis and the directrix. Line of eccentricity. Now, next thing I'm going to do is apply my rule, which works for all conics, at 45 degrees from the focus, and drop back down perpendicular to the directrix, gives me my vertex. My second vertex, 45 degrees from the focus, and drop back down from the point of intersection with the line of eccentricity, gives me my vertex. I'm going to go ahead and find the center of my drawing. From the center of my drawing, I can find the second focal point. Oh, sorry, I just took that point. That was my rise and run. From the center of my drawing here, I'll take my focal point and I can mirror it across the center point. So there's my other focal. I could also draw the major auxiliary circle right now if I wanted. So there's the major. Just going off page a little bit. So major auxiliary drawn there. And if I wanted, I can also draw the minor, so you know, the usual. Half the major from the focal will work up and find the minor. Draw half of the curve, so I might just do this using our usual method. I might put a little bit of colour into this now so that it stands out. And I'll add 1 point there between the focus and the vertex, and I've about 50 mil there in the centre. I'll just, 1734, and when we're up to, that's approximately 51. I'll take those 3 yellow marks I just had right there, and I'll bring them up to hit the line of eccentricity. I also need the latus rectum. I'll bring all of my yellow marks onto the latus rectum. Which I should do the same for the center line as well. And that center line hits exactly on the line of eccentricity. And finally, from my focal point along the line along the latus rectum, I'll rotate them back down onto their ordinates to find the position of a point on each ordinate. So that's a point in the curve where the latus rectum hits the line of eccentricity, and then we just join up to all of the other points that we have just found. Now, I'm going to mirror my points across the axis. That is the height of the latus rectum, so that is just there, a point in the curve. And I mirror them all across. So now that is the first part of the question. Now accuracy is kind of coming against me here at the top. Probably should have gone ahead and found the minor using half the major from the focal. I'd probably find it to be a little bit higher, but anyway, I'll go on ahead with it for now, because I'd like to get on to the next part of the question here, which is the tangent. Draw a tangent to the curve which makes an angle of 45 degrees with the axis, showing clearly how the point of contact is obtained. Now we can go and we can draw this curve here on the left, 45 degree, or tangent, sorry. We can draw a tangent on the left 45, or we can draw it on the right here at 45 degrees. I'm going to draw it on the right hand side. Now what we do is this, okay? We can draw a tangent, we can draw a line at the given angle, anywhere out there. You can go at 90 degrees to that line from your focal points. And I've already done it from here. So that gives me them 2 points right there. But the more important ones is where it hits the major circle. Okay, so where that one hits the major circle, I want to take my compass and I want to just take the distance from the major auxiliary back into the focal point, and I just want to rotate it across that point. So I've just taken, basically I've taken my 45 degree line and I've gone normal to the 45 through the focal point to get a point on the major. I've taken the distance from the major point back into the focus and brought it across. And if I join that point right there back to the second focus, I get a point of contact, POC. And my 45 degree line moves on in. What we'll also find is I can extend that on as much as I want in each direction. But we'll also see there, you might have seen as I was drawing it, it touches the very same 2 points on the major that were found when I went out with my original normals. That's how we find an exact point of contact there for a tangent at a specific angle to an ellipse. Hope this video helps, and I have a couple more to upload on some of the remaining difficult questions on conic sections. Thanks very much.